Now, let's apply Coulomb's law and solve this problem. This problem says find the force of repulsion between two protons of 1.6 times 10 raised to the power negative 19 coulombs each if the distance between them is 5.3 times 10 raised to the power negative 11 meters. We are given the constants to be that. So from Coulomb's law, the force of repulsion or attraction between two charges is given as F equals K charge 1 charge 2 upon R squared. So we're going to substitute in this formula to get the force of repulsion between them. So on substitution, F1 equals K, the constant, which is 9 multiplied by 10 to the power 9 multiply charge 1, which is 1.6 times 10 raised to the power negative 9, multiply charge 2, which is still the same in magnitude as 1.6 times 10 raised to the power negative 9, everything divided by r squared, that's the square of the distance, 5.3 multiplied by 10 negative 11 squared. So this is what we are going to evaluate. Then F1 will be equal to, this is 9, we'll say 9 multiply 1.6 multiply 1.6 again, then multiply 10 to power of 9, 10 to negative 19, everything upon 5.3 squared, 28.09, then multiplied by 10 to negative 22. When you square 10 to negative 11, that gives 10 to negative 22. So let's evaluate this. This is 23.04. So our F1 equals 23.04 multiplied by 10 to the power of half minus 29 here in the power, and we have 28.09 times 10 negative 22. So our F, you can call it F. I think there will be no need for F1 since we're just looking at one force. So it's just F. So we're going to have 23.04 upon 28.09, then multiplied by negative 29 minus into minus 22, that is indices. The number of the same base divide, you subtract their powers. So F will be 23.04 divided by 28.09. That gives us 0.82, then times 10 raised to the power. Here will be negative 29, then plus 22. So F equals 0.82 multiplied by 10 to the power of negative 7 Newton. So that gives us 8.2 multiply 10 to negative 8 Newton. So that is the force between the two protons, this and this, the force that exists between them. Now, look at this question. Three charges, 10 Coulomb, minus 20 Coulomb, and minus 16 Coulomb are distributed as shown below. Find the resultant force acting on the 10 Coulomb charge, this red one. We're looking for the resultant force on this red one. Now, let's look at them this way. This 10 Coulomb and this 20 Coulomb, there is attraction between them because this is positive charge and this is negative charge. So there is attraction between them. So there is force here, which we're going to call F1, force of attraction between them. Now let's look at this 10 Coulomb and this negative 16 Coulomb. There's also another force of attraction between them, which we're going to call F2. So our job is now to get F1 and F2, then we compute the resultant of F1 and F2. So let's begin with F1. So for F1, this will be K charge 1 charge 2 upon R squared. So F1, remember F1 is force between 10 Coulomb and 20 Coulomb. Then K value is this. So we're going to substitute 9 times 10 raised to the power 9, that's for K, this value, multiply by charge 1, that is 10, by charge 2, which is 20 Coulomb. So we're going to say times 20 Coulomb here. Everything divided by square of their distance. They are 3 meters apart. So that will be 3 3 squared. That will be 3 squared. Alright, so our F1 will be equal to 1800 multiplied by 10 raised to power 9. Everything divided by this is 9. So F1 will be equal to 200 multiplied by 10 raised to power 9. That is 2 times 10 raised to power 11 Newton. So that is our F1. Okay, we're going to proceed to get our F2 on the other side of the board. So our F2 will be K Q1. Of course, this is our Q1. This is our Q1. We call this Q2. Then this is going to be our Q3. So we're going to Q1, Q3 upon R squared. So F2 will be 9 times 10 raised to the power 9 multiplied by Q1, which is 10, multiplied by Q3, which is 16. Everything divided by 2 squared. So our F2 is 1440 by 10 raised to the power 9 divided by 460. So our F2 will be 360 multiplied by 10 raised to the power 9. So our F2 will be 3.6 multiplied by 10 raised to the power 11 Newton. So we've gotten our F1 and F2. So let's look at the resultant of F1 and F2. Remember, this is our F1 and this is our F2. Okay, so we're going to draw a resultant here for them. So this be the resultant of both of them as a resultant for R. So we can complete this way to form a right angle triangle, right? So we can use Pythagoras theorem. If here is F1, then here also is F1. So by Pythagoras theorem, R squared should be F1 squared plus F2 squared. So R squared should be F1 is 2 times 10 raised to the power 11 squared plus F2 3.6 multiplied by 10 raised to the power 11 squared. So our R squared will be 4 multiplied by 10 raised to the power 22 plus 3.6 squared. That is 12.96 multiplied by 10 raised to the power 22. Alright, so R alone will be square root of 4 plus 12.96 multiplied by 10 raised to the power 22. So R will be square root of 4 plus, of course that will give us 16 plus 96, then multiply by 10 raised to the power 11. When you take square root of this, it gives you 10 raised to the power 11. So R alone will give us, that is 4.1. So the resultant is 4.1 multiplied by 10 raised to the power 11 Newton. So this is the resultant force acting on this charge, 10 coulombs. So we can look for the resultant. Sorry, we can look for the direction. We can call here theta, and when we take the tan of theta, tan is opposite, which is F1 upon F2. So tan theta will be F1. Our F1 is 2 times 10 raised to the power 11 upon F2, 3.6 times 10 raised to the power 11. This will go with this. So this gives us 2 upon 3.6, which will be 0.5556. So that gives us 0.56. So our theta is tan inverse of 0.56, and that gives us 29 degrees as the angle.